Let's start with a circle. The green dot represents the center of the circle. Let's draw a line passing through the center of the circle so that each end of the line touches the triangle edge. This is the diameter of the circle, but it can be described in a different way as two separate lines, each starting at the center and then going in opposite directions and ending at the edge. So there's a right-hand line going from center to the right edge, and then a line on the left-hand side going from center to the left edge. Given that both of these lines go from the center to the edge, they are both exactly the same length. In fact, they are the same length as the radius of the circle. And that's why they look like the radius, because they are, in fact, the radius. This property of lines that are the same length as the radius will be very important to us later on. Notice that we've also created two semicircles with the diameter. Now, let's select one point on the edge of the upper semicircle. Draw a line from this point to the left-hand side of the diameter and also to the right-hand side of the diameter. We now have a triangle in the semicircle, with the diameter of the circle is the base of the triangle, and the tip of the triangle is touching the edge of the circle or of the semicircle. There is a circle theorem that states that this angle must always be a right angle. And using some rules that you already know about triangles, we're going to show why this is true, that this angle must be a right angle. Okay, we can begin by giving this angle a special label so that we can come back to it later. Next, I'm going to draw a line from the center of the circle to this angle. As we said before, because this line goes from the center to the edge, it is the length of the radius. And that means that it's exactly the same length as both sides of the base. We saw those earlier on. Here they are again, just in case you'd forgotten. The result of adding that line is that we've created two triangles out of the one. Let's label those. Call the left-hand triangle A and the right-hand triangle B, and we'll give X the angle symbol so that we don't confuse it with the letters A and B, which are triangle labels. Now look at triangle A. We know that this length here is the same as a radius, and this line, which goes from center to the edge, is also the same as a radius, which means that triangle A has two edges that are of the same length, this one and this one. And we know that when a triangle has two edges that are the same length, it is an isosceles triangle. So let's add the indicators. But we also know that, yes, this is the length of the radius, but so is this line as well. So triangle B has two edges which are the same length. It's also an isosceles triangle. Let's add the indicator. Since the angles in an isosceles triangles that are adjacent to the base are the same, in triangle A, the base angles are the same. Let's give them a label. What's true for the left-hand side triangle must be true for the one on the right-hand side. So the base angles must be the same. Let's label these. Now, if we look back at this as one triangle, we have an angle of the left-hand side base, which is A, an angle on the right-hand side base, which is B, and two angles make up this angle, which means the value of X is A plus B. We'll just indicate the base angles A and B with a couple of colors. Then we could say that the angle at the right-hand side of the base, which is this one, plus the left-hand side of the base, which is this one, plus the entire angle of X equals 180 degrees. So let's apply the angle values to this general sum here. We have the purple dot, which is B, the angle B, plus the yellow dot, which is the angle A, plus X, which is a combination of two angles, A plus B, plus A, sorry about my A, plus B. And all of that equals 180 degrees. But we can see that there are two A's and two B's. Here are the two B's, and here are the two A's. So this really is 2A plus 2B equals 180 degrees. Since both parts of the left-hand side sum have 2's in them, we can factor out the 2. So that 2, we get 2A plus B, because if you expand them, you get 2A plus 2B, which is the same, and that equals 180 degrees. Both sides of the equation is divisible by 2. We can divide 2 by 2 and 180 by 2. If we divide 2 by 2, they cancel, and 180 divided by 2 gives us 90 degrees, which means that A plus B equals 90 degrees. But going over to the circle, you can see that X equals a combination of A and B, so X must be 90 degrees, which means that we've shown that the angle in a semicircle, that's the angle that's opposite the base, is actually 90 degrees. And as you know, 90 degrees is a right angle, and therefore this is always a right angle according to the circle theorem.